8876. The purpose of cascade vanes in a thrust reversing system is to A. Form a solid door in the jet exhaust path. B. Tum the exhaust gases forward just after exiting the exhaust nozzle. C. Turn to a forward direction the fan and or hot exhaust gases that have been blocked formatting through the exhaust nozzle. The correct answer is C. The purpose of cascade vanes in a thrust reversing system is to turn to a forward direction the fan and or hot exhaust gases that have been blocked from exiting through the exhaust nozzle. Cascade vanes, also known as blocker doors or cascade vanes, are used in thrust reverser systems to redirect the flow of exhaust gases. When the thrust reverser is deployed, these vanes move into the exhaust stream and redirect the exhaust gases forward, creating a reverse thrust effect. By redirecting the exhaust gases, cascade vanes help to slow down the aircraft after landing. 8877. Turbojet and turbofan thrust reverser systems are generally powered by A. Fuel pressure, hydraulic pressure, and pneumatic pressure. B. Electricity, hydraulic pressure, and pneumatic pressure. C. Fuel pressure and electricity. The correct answer is B. Turbojet and turbofan thrust reverser systems are generally powered by electricity, hydraulic pressure, and pneumatic pressure. Thrust reverser systems require various sources of power to operate effectively. They often rely on a combination of electrical, hydraulic, and pneumatic systems. Electricity is used to power control mechanisms and actuators. Hydraulic pressure is used to actuate the thrust reverser mechanism, and pneumatic pressure may be used to assist in deploying or locking the thrust reverser components. 8878. The rearward thrust capability of an engine with the thrust reverser system deployed is A. Less than its forward capability. B. Greater than forward capability. C. Equal to forward capability. The correct answer is A. The rearward thrust capability of an engine with the thrust reverser system deployed is less than its forward capability. While thrust reversers are effective in providing reverse thrust to slow down an aircraft after landing, the magnitude of reverse thrust generated is generally less than the forward thrust capability of the engine. The reverse thrust helps in decelerating the aircraft on the runway, but it is not typically as powerful as the forward thrust used for propulsion. 8879. Which of the following statements is true regarding thrust reverser systems? A. The reverser system must be able to withstand high temperatures, be mechanically strong, relatively light in weight, and reliable. B. Engine thrust reversers on the aircraft usually will operate independently of each other. C. Mechanical blockage system design permits a deployment position aft of the exhaust nozzle only. The correct answer is A. Regarding thrust reverser systems, the statement that is true is the reverser system must be able to withstand high temperatures, be mechanically strong, relatively light in weight, and reliable. Thrust reverser systems are critical components of an aircraft's propulsion system. They must be designed to withstand the high temperatures generated by the exhaust gases, be mechanically strong to handle the forces involved, lightweight to minimize the impact on aircraft performance, and reliable to ensure proper operation during critical phases of flight. 8880. What is the proper operating sequence when using thrust reversers to slow an aircraft after landing? A. Advance thrust levers up to takeoff position as conditions require. Select thrust reverse. Deselect thrust reverser. Retard thrust levers to ground idle. B. Retard thrust levers to ground idle. Raise thrust reverser levers as required, and retard thrust reverser levers to ground idle. C. Select thrust reverse. Advance thrust reverser levers no higher than 75% of NI, and retard thrust reverser levers to idle at approximately normal taxi speed. The correct answer is B. The proper operating sequence when using thrust reversers to slow an aircraft after landing is to retard thrust levers to ground idle, raise thrust reverser levers as required, and retard thrust reverser levers to ground idle. After landing, the pilot reduces the thrust levers to the ground idle position. Then, the thrust reverser levers are raised as needed to engage the thrust reversers. Once the aircraft has slowed down sufficiently, the thrust reverser levers are returned to the ground idle position.